Hello students, in today's class we will learn about different types of sets. In the last class we studied about the definition of set, right? So the definition of set was it is a collection of, or we can say it is a well defined collection of objects, right? So this word well defined is very important, correct? So we cannot say every collection as a set, right? So we also studied the different representations of a set. One was roster form and the other was set builder form, right? In roster form we used to write the elements in curly braces separated by commas, right? Like this. In set builder form, we used to build a set. For example, it is a collection of all such x such that x satisfies some property, right? So this was the kind of representation that we learned in the last class. Today we will learn about different types of sets, right? And please be informed that I will strictly refer to NCERT and its examples and exercises in all my sessions, so that it's easier for students to go through all the topics from NCERT itself. And please understand that learning it's important to understand the concept instead of just running after the problem, solving the problems. First understand the concept and then try to solve any question, right? So number one is empty set. Empty, what does empty means? Empty glass of water is a glass which does not have any water, right? So similarly we have an empty set. It means we do not have any element inside this set, correct? So it is also denoted by phi, and it is also called as null set or a void set. Okay, empty set or null set or void set, these are one and the same things, right? Now let's look at one example. For example, all such x belonging to real numbers or all such x belonging to set of natural numbers, right, such that x is even and x is odd. So does this set have any element? No, this is empty, right? If I denote it by a, so the set names are denoted by capital letters and the elements are denoted by small letters, right? So if I denote it by a is basically empty, right? It does not have any element. It's a null set, it's a void set, right? So any natural number cannot be even or odd at the same time, right? So one example is this. Another example could be like set of all students who are currently studying in class 11th and class 12th, right? Now is this an example of an empty set? Yes, it contains it does not contain any element because the student can either study in class 11th or the student can study in class 12th. The student cannot study in both the classes simultaneously, right? So it does not have any element, correct? So this is the definition of an empty set. And let's look at some other definitions, some other examples as well. For example, can you give me a number, a prime number which is even and greater than 2? No, there does not exist any even prime number greater than 2. 2 is the only even prime number, right? So if I say a set A as a collection of objects, right, or a collection of all such numbers which are even prime numbers and greater than 2, so that set will be empty. So that is one of the examples of the empty set, right? And if I say what is a finite set? A set which has a definite number of elements, right? If I can say the set of all natural numbers, is it finite? It is not finite, right? Because it does not have a definite number of elements that you can count, right? So for example, 1, 2, 3, right? And the number of elements of a finite set, if S is a set, then the number of elements of this set is denoted by n of capital S, right? So this gives us number of elements or count of elements in the set, right? Okay. An infinite set is a set which is not finite. Correct? Alright. So infinite set is a set which is not finite. For example, I can talk about 1, 2, 3, and how do you represent it? You have to write few elements of the set and followed by 3 dots, correct? So this is how you represent an infinite set. And when I say what is an equal set, I mean, when do we say that two sets are equal? A and B are said to be, let A and B are sets, right? When do we say A is equal to B? It means that if every element of A, it means A belonging to A, this symbol is for belongs to. It means A is a member of A, right? A belongs to A implies that A belongs to B, and A belongs to B implies that A belongs to A, right? So basically, if every element of A belongs to the set B and if every element of B belongs to the set A, then the two sets are said to be equal. It means that indirectly we are trying to say that the two sets A and B have exactly same elements. They are exactly same. Let's take an example of equal sets, right? Let's take an example of equal sets. If I define A as right and B as, are these equal? Yes, these are equal, right? If I say A as, because one belongs to B, right? One is present in A and one is present in B. One belongs, two belongs to A and two belongs to B. Three belongs to A and three belongs to B. And every element of B also belongs to A. So they are equal, right? So if I say if A is a set and B is 2, 2, 1, 3, 3. Although the elements are repeated, but in case of sets, the repeated elements are immaterial, right? So the order of elements is immaterial, and even if the elements are repeated, that is also immaterial, right? So actually the elements of the set are 1, 2 and 3. That is why these two sets are said to be equal. So in first example we saw that the order doesn't matter, and the second example is indicates that the repetition does not matter, right? So even if we repeat some elements in the set, it means if 2 belongs to the set B and we write it 2 times, doesn't matter. It will still be the same element 2, right? It will not be a different element. So let's also go through the NCERT and we will cover some of the good examples from the textbook. So as I explained, empty set is a set that does not contain any of the elements. So one example is that X is a student presently studying in both classes 10th and 11th, which is not possible. So this set is empty. We also call it a null set or a void set. Let's discuss this one example. X, this is a set of all values X which satisfies the equation x square minus 2 is equals to 0, and X is a rational number. Do we have any rational number that satisfies this equation? No, because the roots of this equation are plus minus root 2 and both of them are not rational. So that is why this set is empty, right? It does not contain any element. So if I talk about finite and infinite sets, finite set is a set which has definite number of elements, or it can be empty, right? Either it does not have any element or it has definite number of elements. For example, let W is the set of the days of the week. So this is finite. Roots of the equation x square minus 16 is equals to 0, which are plus minus 4. So that is also finite. Whereas G is a set of points on a line, that is infinite. We cannot count the number of points. Or the if I talk about the set of real numbers R, that is also infinite. We cannot count the number of real numbers, that is indefinite, right? Set of all natural numbers is also infinite. So let's look at these examples. State which of the following sets are finite or infinite. X, all such X such that X is a natural number and it satisfies this equation. So this actually boils down to the roster form 1 and 2. It has only 2 elements because 1 and 2 are the roots of this equation. So this is finite. Second one is also finite because the roots of this equation x square is equals to 4 are plus minus 2, but since it's a natural number, so we will consider only 2, right? So this set is again finite. 2x minus 1 is equals to 0. So the root of this equation is 1 by 2, but that is not a rational number, so that is empty and hence it is finite. Empty set is also a finite set. And if I talk about all such all natural numbers and which are also odd numbers, right? All odd natural numbers, so they are infinite. So that is why this set is infinite. Now let's look at examples of equal sets. So first of all, the definition says that two sets A and B are said to be equal if they have exactly the same elements and we write A is equals to B. So otherwise the sets are said to be unequal. It means if I say A is this and B is this, the order is different but the elements are still the same, right? So that is why both of them are equal. So A set does not change if one or more elements of the set are repeated. So we saw that even if there is a repetition, it does not matter. Even if the order is different, that does not matter. Still the sets will be the same if the elements are same. So two sets are equal if they have exactly the same elements, right? So we have also some we write A is equals to B or we write A is not equals to B, correct? In the next class we will also talk about subsets, right? And we will also define equal sets again in the subset notation, right? So after learning what is a subset, we will define in the notation of a subset how two sets are defined to be equal. So in example 7 we have find the pairs of equal sets if any give reasons. So A is 0, B is all such X as X is less than 5 and greater than 15, B is empty, right? There's no number which is less than 5 and greater than 15 at the same time. C, X is equals to 5, so singleton set 5 is a see any set that has only one element is called a singleton set. So X is equals to 5 is the solution, and in D we have X square is equals to 25. It means X is plus minus 5, right? So and here X is an integral positive root of the equation x square minus 2x minus 15, right? We know that It should be, okay, it should be minus 5 and plus 3. So I think E, this B was empty, C was singleton 5, D was plus minus 5, so they are not equal. E is still singleton 5. Okay, so that is why C is equals to E. Okay, for that one should know how to solve this quadratic equation. Okay, we should know how to find the positive, and they are saying integral positive root. We are talking about the positive root, not the negative, although it has two roots, but we are talking about the positive root, and that is plus 5. Okay, so let's quickly go through the exercise also. Which of the followings are example of the null set? We will take up only one or two from this, right? Set of all odd natural numbers which are divisible by 2, that is empty because no odd natural number is divisible by 2. Okay, and set of even prime numbers, we do have 2 is an even prime number, so that is not empty, that is not a null set. First one was a null set, and then we have x is a natural number, x is less than 5 and x is greater than 7, that is again null set. Okay, and then we have the second question, which of the following sets are finite or infinite? The set of months of a year, that is finite. Second one is infinite. Wherever we find three dots, that is an infinite set, because wherever we cannot represent a large set, that is infinite. But still here, since that is in between, right, so that is a finite set. Again, that is not infinite, we can count them from 1 to 100, right? And the set of positive, a set which is a never ending set is basically infinite. The set of positive integers greater than 100, that is again infinite set, because we do not know till where we have to go. There are a lot of positive integers greater than 100. Now state whether each of the following set is finite or infinite. Again, I think that is very easy to cover. um, let's look at this. Are the following pair of sets equal? Give reasons. 2 3, x is a solution of x square plus 5x plus 3, right? So you need to find out the roots of the equation. I will not be solving the complete problem here, but it's just that you need to find out the roots of the equation and verify whether it is equal to a or not. And for example, if a and b, a is, x is a letter in the word follow, and how many letters are there inside this? W, O, L and F. 4 letters are there, right? So the set is exactly, if I write it in roster form, it is WOLF. And again, B is saying why is a letter in the word wolf, that is exactly, so A is equals to B, right? In this case, A is equals to B. Now in next session we will learn about subsets of the real set, the set of all real numbers, right? And we will also talk about intervals, which are again a subset of real numbers. So till then, please complete this exercise 1.2.